So, good afternoon and welcome back to the session for Graph Neural Network. What we have covered in the past two sessions, we were just beating around the bush and we were covering the basic. We were building the basic knowledge about the terminologies, about the concept that we will be using throughout the course. The reason why we devoted around 2 to 3 hours on those topics because from now onwards, we will be directly using those words. The meaning, the concept behind those keywords will not be explained now. Okay. So in that case, if we all are at the same platform, we can directly communicate the inner meaning of the whole sentence that we are going to use. So suppose, for example, unless you know um, what is the isomorphism problem, why, what is the pair areas of graph isomorphism, why that problem occurs in a pattern mining or something, some similarity and all. So until and unless you know those pain areas, you won't be able to understand fully. Or is there any doubt? Okay, so what I'll do is for the initial 10 to 15 minutes, I will revoke the rights of the speakers. Okay, so that because there's a slight problem with the Teams key. If you rejoin or if you rejoin multiple times, then by default sometimes the speaker is unmuted. Okay, so when everything is settled up, I'll provide those rights again. Okay, we were talking about why we have devoted and why we were slow and devoted too much of time in those keywords. The reason being is because this is purely research based and still the model that whatever you are working is nothing is ready made. Okay, you won't be able to get everything or anything ready made. You might have something already built in parts. So you'll have to assemble those parts to fit it into your own problem or to get the solution of your own desire. Okay, so when it's like plug and play, there are many things which are available. You need to assemble all and then you need to club them to try for a solution. Sometimes you may not reach to a solution. Sometimes your method may not be correct. Okay, or sometimes nothing works out. Okay, so at the end you can come up. Okay, so that means this technique cannot be applied on this concept. Means you'll have to change many things altogether. So that's why in order to understand the basic concept, or if everything works good, then that's fine. But if some changes need to be done, if some improvement need to be done, that can only be implemented or that can only be suggested if you know in and out of many things or almost all the things. Okay, and as this is currently in India, we are still in a growing phase of neural network or those deep learning and all. I know that the book that we are following, the graph neural network frontiers and that book, that books contains many topics, many papers which are, or many references which are the thesis of the students, of the persons from the Stanford or from China, many more. But in India, we are still in a growing phase of that we have newly introduced this course. They have completed their PhD, but we are still start using those keywords into our own day-to-day work. Okay, so that's why we can say we are still in a initial phases of deep learning. Okay, so that was beating around the bush. Let me answer the query if there is any. Then we'll quickly move to the topic that we intend to cover so far. And I started the recording. Yes, I did. Okay, so as there is no question, I'll assume that everything is being resolved and it's time for me to go ahead. Okay, this I have already explained you. Okay, degree and degree distribution. We will look at this point. We'll look at this distribution, not exactly the degree distribution. We'll look at this distribution with a different perspective again later in this lecture. So this you know. Okay, let's move ahead then. So the graph, which arises in many large-scale applications such as web or social media or this chemical and bioinformatics, they have many properties, or almost all of them satisfy some properties. Those properties can be degree distribution, the power law distribution, sparsity, small diameters, densification, shrinking diameters. Those keywords, you may have a bit of intuition. What are they? Okay, so diameter means something we are talking about the size. Okay, sparsity means something we are talking about the clusters and the connectivity. Densification means in terms of degrees. Okay, increasing degree size. And shrinking diameter means somehow the size is shrinking. So these are few properties, and just by looking at the names, you may have a bit of intuition, okay, what it might be. And the word which I have not explained was the power law. Power law is something, so power law distribution means something like power means something that's in command, and somehow that is command is being distributed, so something like this. So these are the few properties that every graph have, large graph have. Okay, we look at each property in not full detail but a slight detail in this lecture. But before that, because all the properties that we have been that has been listed in this slide, they are structural properties. Okay, these are the properties that can be that can be extracted out, or that can be explained based on the structure or the connectivity of the graph. So the question arises, why the structure of the graph is so important for us? Why should we study? So if we know, if we are trying to study the structure of a graph, we should be able to answer some of the questions, such as how does a web look like? As of now, web means a search box of a Google in any of the search engine. Okay, either Google, or if it is research, then ResearchGate, or many other things. If it is something related to social media, then your Facebook page and your connectivity or something like this. If it is YouTube, then you log in along with the list of recommendations. So for you, the web is something, a web page which appears in front of you. Okay, but internally, how does it look like? What is the internal connectivity of all the type of network that we are working on? So until unless, if you're using it, then that's fine. We have nothing to do with the internal network. I just type something on a Google search engine, search bar, and it gives me a list of input. That's all. I'm not bothered about how they have done it, why they have done it, even the sequence of the web pages. I'm not bothered about. I think I have shown you about the search, how much web pages it has searched, how much time it have taken. Okay, to what extent he had created a list of those similar document. If I'm not bothered about it, I need not to study the structure. But if I'll have to analyze the structure of a graph, because to say something about anything, I should know that thing. Okay. So how does the web look like? If I can answer this question only if I have a bit of idea about the structure of that type of network. How about social media network like LinkedIn and Facebook? What is the internal connectivity? How, based on what they are recommending me something, some feeds or some videos or some messages, something. Okay, they may have an internal algorithm that works and that gives me an output which for me are more relevant. Okay, so if I just type something on a Google search engine and I receive something garbage, then immediately I will not be using that search engine. I will immediately quit that search engine and search for something better, which gives me those list of those web pages which are more relevant to the search which I have fired. Okay, so that means to make something better, someone who have to who's working at the back end should know the structure of a graph. Suppose, for example, the Facebook. If I'm getting the recommendation videos which I'm not interested, okay, so slowly and steadily, if those kind of videos or that Instagram and all are coming as a recommendation to myself, which I doesn't like. So if I doesn't like, I will move out of that social media. So if that social media, that LinkedIn, not LinkedIn, Facebook, YouTube, Instagram, Twitter, if they want to capture my attention, they want to recommend those, they should have those kind of algorithm which are of my interest. So they should show me what I want to see. If they're able to do that, they can, I will be devoting much time on that platform. Okay, so that means somehow that should match my interest, and my interest may vary from yours. You may like to watch something else. Okay, so that means for you, the videos or these recommendation, whatever it be, will be based on your interest. So that algorithm should be fine tuning those list of those recommendation based on something which the web page or my system, my Android device have captured, or your Android device have captured. Okay, so that means something internally they should know to make the system better. So algorithm should be capable enough to capture my interest, to show me the to provide those links which I want to see, and that may vary from you. You may have different interest. You may be expecting a different set of web pages into your Android phone. For that, you should know. So is it normal to have a person have a 500 friends? It's merely a statement, fine, but a node with 500 edges, is it normal? No. Is it normal to contact all the structures, all the 500 with equal frequency? Means in terms of connectivity, in terms of flow. So the flow means I'm connecting, I'm sending a message to all of my 500 friends daily, okay, or weekly. Is it normal? No, that is not normal. That is something abnormal. Okay, so that means if I'm broadcasting every message to all, it may be I may have gone mad. Okay, or it may be that something unusual has happened to me. So that's why I'm just broadcasting something to all of my network so that all of should know. It may be my last message also. Okay, so even if someone comes up if someone sends a broadcast message with some text, so the Facebook or any of those social media can raise an alarm to the local police station that something has gone bad to this guy. Go and check. It may be. So that is not normal. Which are the important nodes in a graph? Nodes, either nodes in a graph or a part of a graph. Okay. So either I'm trying to extract out the important nodes or the important part of a graph. I think we have talked about graph summarization at that time. Okay, so graph summarization means important part, subgraphs of a part. So if I need to answer it, I need to have an idea about the structure of it and how to access it, how to process it. So in all those things, there are few activities to identify. First of all, I'll have to come up with a statement what a normal is. For me, what is normal? Okay, so that condition for the normal varies based on scenario. For something, for sometimes something may be normal to me. It may not be normal to someone else. Okay, so that normal criteria has to be defined. And based on that, whatever goes beyond it can be considered as anomalies, strange or abnormal behavior, outlier detection, anomaly detection. Okay, so like something like in your phone calls nowadays, you might have observed that the service provider itself suggests whether a phone a call which you're which you're just ringing on your phone is a spam or not. That's not 100% algorithm, but still maybe a spam or not. Based on the number, you can decide. Based on the scenario, you can decide whether that can be a spam or not. So, for example, usually whatever messages, whatever calls I receive as a spam, I usually ignore it. Okay, but at the time when I have booked a cab, okay, or some order is to be delivered at my home, then by default that vendor, that cab guy, that the delivery person may call me through the network, not through his personal phone, through the network of Uber, Ola, what Rapido or Amazon or Flipkart, whatever it be. They may be calling through the server. Someone might have put it on a spam, or many of them might have marked that as a spam to them. So they may still be shown as a spam, but based on the scenario, now you know that it has been identified as a spam by the server, by the network, but it's not a spam. It is the delivery guy, it is the driver who is calling you. So if you ignore it, they leave it behind. They leave you behind or take or return the box which you are expecting. So that normal, what is normal and what is abnormal varies based on the scenario varies. Okay, fine. Weird example, but somehow. Okay. And based on the just like normal, I need to have some method for identifying important also. For me, what is important, for some other person, it may not be that important. Okay. So what to be focused on and what can be ignored. There should be a specific criteria for that also. So a graph encompasses a large number of applications, social media, social network, Facebook, LinkedIn, who call to whom network, who text to whom network, who collaborate with whom network. And all those networks are different from each other. And but if we need to extract out something, if we need to predict out something, whether that should be an anomaly or not, whether that should be a spam or not, we need to have we need to understand the structure of a graph. Based on the structure only, we can say whether that is a spam or not, or whatever recommend, whatever prediction we want to make, that should be based on the structure only. So for a cybersecurity computer network, the goal are to spot the strange behavior like botnet, port scanners, and extra filtrators. Okay, so somehow even your antivirus or whatever it be, Kaspersky and many more, Quick Heal and something, they are predicting, or they're identifying whether a particular web page which is you trying to take a look at, a web page which you're trying to serve, or we can say access, a web page which you're trying to access is spam or not, or may contain some virus or not, or is it safe. Web and ranking, influence propagation. Okay, so influence propagation, there's another name which we call it as belief propagation. Okay, let's talk around 5 minutes on this. Or the another name can be trust propagation. Okay, so propagation means it is flowing through the network. Okay, so somehow if you're given with the graph, some of them are labeled, okay, and some of them are unlabeled, like a classification. So let me explain it in that way. Suppose you visit any of those e-commerce sites, okay, then what are the first filters, or what are the um, steps you follow while ordering any item which you have not bought it before? You have no idea about any some product which you are looking for now, because all those e-commerce site provides hundreds of such item whatever you are looking for. So you need to filter out which product, or which type of product you want. So they give you a number of filter options to choose your own. So the first thing that you do is 4+ rating. Nowadays, Amazon has included one more filter, 4.1 star rating and above. Okay, earlier it was 4 and above. Now it is 4.1 and above. Also, it is available. So what is that you are doing based on the rating? Okay, so based on the rating of those product, you are building a trust on a particular set of product. So suppose you filter out something. Let me give you a live example. Just help me in uh, searching for anything. Please help me. Give me a product which I need to look at. I just want that to be interactive. So as if you all are listening to me, suggest a product which I should search on an internet. Anything. Face mask. iPhone has no option. iPhone means iPhone. So phone face mask. Okay. The moment I say face masks, I have many options available now. So 4+1, 4+, and 4+1. So I eradicate all the web pages or all the nodes which falls below that rating. Okay. Then what I'm doing is, suppose I am a good user. Okay. So I'm a good user, and after buying a product, I'm giving the reviews also. Now, after 4+1, what is the second criteria? Second criteria, I'm looking at the number of users who have given those ratings. So that means this product have been bought by 40K person, 5.96K, 2.2, 249, 960, 528. Okay, 17,000, 24,000, 5.8 thousand somehow. Okay, some product may have 5 rating, but it have been bought only by 2%. It have been ranked by or rated by 3% only or 1% only. I'm not going to buy it. Okay, that that reviews may be biased also. Okay, even 4.8, but only 141% have given the rating. Okay, so that means that may not be correct. So second, that is the first thing, and then how many person have bought it in the last month? So 1,000 have bought in the past month, 3,000 have bought in the past month, 8,000 have bought it into the past month, 450 have bought, 1,000 have bought, and something. So that means if my criteria is number of reviews and then how many person recently bought. Okay, so suppose for example this one. So 2.2, 5.9. Okay, that means this may be a new product. Recently might be providing some offers or something. Okay, so that means somehow I will try to explore this item. Okay, so somehow that influence is being propagated across the network. Okay, so I trust something, then I give my reviews, and those reviews are read by someone else, and they are being followed by something, and then some are liking those reviews, some are disliking those reviews. So somehow the trust or the influence or anything is being passing through the network. Okay, so I'm not bothered about those things. Why it is 11,000? Now go back. I'm just bothered about the original product only, not its the version. Sorry, my network is slow. It is taking too much of time. So somehow it has been reviewed by those. So I go back and read the reviews. Okay. Better option is many of the person will be saying good about the product. Let us read what is bad about it. Okay. So that means the string are very delicate. So that means they usually break. Even with the stretch, they are break. Okay, so somehow if it is was helpful, you just click on the helpful. You may have thumbs up, thumbs down, many other emojis, and this is how you convey. And then I think in the Amazon, you there's one more option. Key, how many of you, how many of the others, matlab you have given some reviews. How many other for how many others it was useful. Okay, so that means how was your influence being propagated through that network. Okay, so that's again some sort of propagation, or we can say classification, labeling something which is missing. So that means I'm trying to build up a trust that which product I should buy, and that trust I'm building up based on the or based on the reviews, based on the structure of the graph, whatever it be. So this is how, means it may be a possibility. It can be a different set of, but it can be a classification problem also. So suggesting something, suggesting some properties or some labels to an unlabeled node or edge based on the labeled data. Okay, so that's again link prediction or a node classification or something. It can, the same thing can be referred in terms of propagation. So influence propagation or belief propagation or trust propagation. So the thing which is flowing through the network from labeled towards unlabeled node, edges, or subgraph, whatever it be. Okay, but for that also we need to structure, we need to study the structure of a graph. For the rating, for the recommendation, and all those things, you need to study the graph. Okay, so this was regarding the structure. Why we should study the pattern and the laws that the real graph follow. Okay, To understand the human behavior, so discovering the pattern of connectivity to develop the domain expertise. So something like human behavior, machine behavior, or protein behavior. Protein behavior means the genetic nature. Okay, so either the bioinformatics data. So to understand the pattern, okay, to understand the behavior, okay, so if this is the pattern, this might be the property that is associated by this kind of a gene. If it is a certain kind of activities are there, so that means they may be trying to do certain activity, or they may be planning something. Okay, so for that you need to study the pattern. Unless you know that pattern, you cannot predict anything. Okay, so it is necessary for the decision making as well as for the prediction. Okay, so what the detectives and all those we can say the agents or whatever it is, jasus, whatever it be, whatever the high profile security persons, they used to identify. They used to identify the patterns. Based on that pattern, they used to predict anything. Anomaly detection. So in order to find out anything strange, you need to identify what is normal. Anything abnormal means you need to study the pattern. Okay, so anything which is going out of that pattern can be the anomaly. Okay, so extremely long and short diameters with respect to 6 degree of separation. Okay, this I'll explain. 6 degree of separation I'll explain, but somehow it turns about the connectivity, the normal connectivity of a graph. Okay, so anything which is not normal, either a very short length or a very long length, it may be suspicious. It is also used for the prediction. Most of the time throughout the course, we will be doing this only, prediction. Okay. Ultimately, GNN is nothing. It is the prediction on a graph data. Generate design. Huh? So until so that for this process also we need to study. We need to know how are the real graph behaving. So if we'll have to generate any graph artificially, then we should know how the real graph looks like. What all are the behavior, what all are the patterns which are there in the in the real graph, so that if somehow we can imitate the same, if we can replicate the same into our artificial graph, then we can run the graph in the lab. Okay, for bioinformatics and all. So we are not going to inject the injection again and again on those rats, and we are doing something. We are performing the simulations on on the database that we have. Okay, but whatever the simulation we are performing on our artificial data should be alike the real data. Okay, so we should know how the real graph are look like, so that and what all are the patterns, what all are the rules, what all are the laws are there which real graph follows, so that we can repeat or we can simulate them artificially through the program. Okay, for compression and all those things. So graph compression, web crawlers, Facebook with billions of pages, active users. So while writing, keeping and compressing the historical data is important. So we need to know what is the pattern and the laws of the graph. And older, same as the case when you're older mails in your mailbox. So even in throughout your life, I think you have not even opened the second mail. The first mail is from the Google itself in the Gmail. The welcome mail is from the Google itself. But who was the, you might not have opened the second mail, um, whatever someone has sent to you. Okay, but still that mail has to be accessible to you. So for example, even in this, I should have a capability, because that's again those mails and all those links can be considered in form of a network. So even at this also, at that stage also, I should be able to, matlab my whatever my model is, that should be keeping all the data right from the beginning. So this was the first mail, this was the second mail, this was the third mail, and then the fourth mail was my details, my joining details. Okay, the moment I that ID was created to me. So for that also, all those datas have to be, well, that is an example for graph compression. Although that is not much important, but that's still to be accessible, that's still to be stored somewhere. Okay, fine. I think I have talked a lot. Oh, 45 minutes. No, so 30 minutes. Okay. Now there are few values which we, a few values that we will be talking about in IndiGraph. But moving ahead, mouse GNN books, ठीक है. So sorry to rest of those, Sudarshan, Ajit, and Nimesh. ठीक है. I didn't search anything based on the things, but ठीक है. I just want one object. Okay, now if I'm given with a graph, this is the usual traditional whatever. This graph you won't be finding anywhere. This graph was generated by me only. Okay, randomly with no intention in the mind, but I have used this graph throughout the course for various numerical activities, various problem solving, which we will be doing, or for various execution of algorithm, we will be working on the same graph. Okay. So distance matrix in a graph. So distance here in this case, the graph, although for us it is a graph, but for a computer it will be an adjacency matrix of order n cross n, where n is the number of vertices. Okay. So distance, so we'll be maintaining a distance matrix also. Apart from the adjacency matrix, we will be maintaining a distance matrix also, which contains of the order n cross n, means v cross v, where v is the number of vertices, and which contains positive integers including 0. Okay, where it should be 0, it should be a 0 when two nodes are not connected to each other. So distance value should be greater than or equals to 0, and it is 0 if and only if we are talking about the same node. Okay, so that means if my graph is connected, then we won't be having any value which is 0. There should be some non-zero values. But if it is a disconnected component, then some values, means the distance distance values of two different nodes of a two different component will be 0. Okay, but in this case we assume that our graph, okay, there's no disconnected component in the graph. Distance between two nodes u and v will be equals to distance of v to u, provided that the graph is undirected. Okay, just for the sake of simplicity and to make the thing simple and easy, we will take all the graphs. A default means undirected graph. Okay, so that means reverse direction will also be same. And if the triangle inequality holds, so that means if we have some intermediate node in between, so from u to v, between u to v, if I add some intermediate node, so a, if suppose if this is u and this is v, okay, so distance between u to v and v to u, let's not make it, let's make it to here also. So u to v and v to u will remain the same. But if I add some intermediate node in between, means path between U to V through W. This is the meaning behind this statement. Okay. So through any intermediate node, it should be either same or the path length might have increased. Okay. So by default, there's one hidden thing which is not being mentioned into the in the whole slide. Whenever I'm talking about the distance, so the distance means the shortest path by default. Okay, will not be considering the all other any path which is not shortest. So if U and V is already at the shortest path, if I at the shortest distance between them, so if I add any intermediate node in between, intermediate node to between mein hoga. So if I add any intermediate node, then the total path length either would have increased or would have remained the same. So for example, if it is through G, it would have same. Through V, it would be same. If that would have been through C, and the path length might have increased. So that means that this path through intermediate node, because it was already a shortest one, through intermediate node, definitely either it will be the same or the path length would have increased or path length would be increased. So this is the meaning behind it. Let us try to find out now. Okay, I'll open that file directly. So we will be performing of calculating some calculations based on those graphs live, not live, through an example. Okay, but before that, let me explain you, let me read out few definitions for you. So the diameter in a static graph will be the maximum distance between any two nodes in a graph. Okay, the largest distance between any two nodes. Now there may be a contradiction. Just a minute before I was talking about that every path we are talking about is the shortest path. Then why I'm talking about the maximum. So just hold on. Read this. The maximum distance between any two nodes of a graph, where distance has a different meaning, where distance is the minimum number of hops or the edges or the shortest path. From one node to another node, usually in an undirected way. So that value is called as the diameter of a graph. Okay, so that means that is related to for all nodes of a graph. So diameter is a single value that is associated with the graph. And so first of all, what we will do, we will try to find out all the shortest path for all pair. So all pair shortest path, and from that all pair shortest path, whoever has the maximum value will be my diameter. Okay, so I'm ready to answer any confusion if you do have any. So intuitively, the diameter represents how much a small world a graph is, means how get from one end of the graph to another end of a graph. So I'm ready to answer the questions about the diameter of a graph. If you do have any confusion. This might not be true always. Sham, sorry, I fundamental rights resumed. Yes, Sham. Now you can
Yes,
unmute
sir.
yourself.
So basically, that was for the previous slide, which said
Mhm.
like distance UW plus distance of WV should be greater than equal to UV.
Yes.
So this might not always hold true, right? Until and unless we force like triangle inequality.
No, it will always be true.
No, so suppose there are three cities, and the direct distance could be far, right?
Fine, fine.
Or
So come with an example with this in this graph.
no, there could be some other graphs also, right?
Okay, no issue. We'll draw it. Huh. Three cities.
Huh? And so this
Three
could be
cities.
very far, right? Or some could be nearby placement. Like suppose there is a distance between Chennai to Delhi,
Mhm.
and in between, if we have some city nearby, could it be not less pathwise?
No, in that case, acha. So that means this new node will be considered as W. So now Chennai to Indore and then Indore to Delhi. Either it will be same, it has no effect, or suppose it is Jaipur, or we can say Jabalpur. So this
Mhm.
path will be more.
So that's how it comes as a triangle inequality,
So
right?
that's what it say. From if there's some intermediate node in between, for
Mhm.
any intermediate, for all intermediate node in between, either the path length remains same or increases. So if it is already lying on that path, there will be no impact.
Okay.
Or if it is away, then definitely the path length will increase. And the moment I'm talking about path, so by default it means shortest path.
Shortest path. Okay.
Whenever I'm talking about path, whenever I'm saying path, so path by default means shortest path. Clear?
Yes.
Okay. Now there's acha, but before moving ahead, any clarification regarding
Uh,
this slide?
Sir, I have a question.
G.
So this distance, it's not a Euclidean distance, no, in graphs?
Currently it is Euclid means numbers. So the easiest way of saying matlab Euclidean word is the word given is a difficult word given to anything. Anywhere you have the numbers and those numbers can be subtracted, added, multiplied and divided. So that type of matrices or that type of operations are allowed in that Euclidean space. So Euclidean space is nothing. It is the space in which you are working on those numbers, and those numbers can be added, multiplied, subtracted in something. So here also these are the numbers. If those numbers are the path length, then that's okay. But Euclidean, all the Euclidean rules are not applicable in the graph because you cannot add the two values of a node. So in that sense, that space is not Euclidean.
Yeah, so the distance, it doesn't really relate to any Euclidean values, right?
Huh. I'll explain you after this. I'll clarify your doubt. But before that, I'll have to explain two more words. So Bhupin, any example would be good. Means what type of example you want. So Shyam, you can raise. You can put down your hand. Yeah, Bhupendra. What example you were expecting
This is for
regarding
diameter
the
actually.
matrices and all? This one,
No,
na?
no, yeah,
Fine.
yeah, this one is.
I'll do it. Not to worry. I'll explain you in full detail. Around half an hour, I to uh, to analyze those numbers. Because until unless you understand the basic concept behind those numbers, you won't be able to work on the graph. Okay, fine. So rest everything is good. Number of path and all. There is one word which is, I think you might not have heard so far. Hops. Okay. So for that, let me devote few more minutes to explain what does hop means. So hop by default means jump. Clear? Now, so if this is my node on which I'm working on, so this hop can be considered as edge, or we can say no, not edge. This hop can be considered as a path with a number of edges. Okay, so that means if I'm at F and if I want to perform a jump of one node, it means one hop. Okay, one hop from F. Where else I can land? I can land to H. I can land to F. I can land to C. So C, G, and H are my one hop neighbor of F. Is it one hop clear? One hop clear? You
Yes.
say yeah. Okay, fine.
Basically, the neighboring nodes are one hop.
Ha. Nodes, the neighbors which are one hop away, the nodes which are one hop away. We can say the neighbors which are at the path length of one. Away by one path length. Okay. Just a twist. What will be, thank you, what will be the two hop neighbors? Let me change the color. Two hop neighbors of F means what will be the two hop of F?
I,
Two jumps.
B, and A.
I, fine.
B and A.
Let me change this is not visible. So let me change the color from red to something else. I'll take black. Okay, so one, fine. Two, three, correct?
Yes.
I, B, and A, okay, but it can also be a one hop neighbor again, because if I change the path, it will be F, H, G. So by default, I'm not talking about path, sorry, because path by default means shortest path. So two hops means one jump and two jump. So G can also be my two hop neighbor. H can also be my two hop neighbor. Okay. I is also my one hop neighbor, which has already been traversed. Fine. So my two hop neighbors will be this. Is it good? I don't think there's any confusion. So a node can be retraversed. A neighbor, matlab G was my one hop neighbor as well as G is my two hop neighbor as well. Slightly confusing, no issue.
Got it.
Similarly,
Correct, sir. Just
okay,
like we are taking a different path, moving around and then coming, right?
okay. So it means just okay. Let me explain three hop and then I'll take you into the another world. Okay, three hop neighbors of F, it will be, matlab new will be, suppose I, okay, and then two hop neighbors 3, ठीक है. So it is, no, why D was not a two hop neighbor? D was also a two hop neighbor, sorry.
So there is no direct way to D, right? So it cannot be
नहीं,
2. It has
two hops means now three hop, ठीक है. Sorry.
3 hop. D will come in 3
Three
hop.
hop. Three hop neighbor, new neighbor is J and B.
J, D, A, B.
ठीक है, हाँ. New one which is not been traversed. Fine. So 1, 2, 3. This can also be B, can also be
I.
I B also. ठीक है. नहीं, 3 होना चाहिए ना. एक, सॉरी, 1 2 3, ठीक है. फिर 1 2 3, 1 2 3 H भी है. Okay, so that means G H I A B. They're also my, somehow I have a path connectivity in terms of hopping. They are also my three hop neighbors, and so on. So if I increase
what
the
about-
hop,
Sir, what about F in this for three hop?
how?
Like F, H, G, and back to F. Is that possible?
It is. It can be. If if I can finish at the loop, then even at the 3, ठीक है, also possible. Even C is also the three hop neighbors. Now, and so on. So it can be 4 hop, 3 hop. So that means, what does it convey?
Sir,
When I'm talking
F,
about 1 hop,
so if F is a 3 hop neighbor, it can be a 2 hop as well.
1 hop neighbor can be a 2 hop neighbor, can be a 3 hop neighbor as well.
Okay.
Okay. Now, the hidden thing is, 1 hop neighbors are the direct neighbors, direct friends. Okay, so the means the Facebook friend, matlab, you are sending a request to someone and he is accepting it. He is into your friend list. Fine. 2 hop neighbors are friends of our friends. So 1 hop are your direct neighbors. 2 hop are the indirect neighbors of any node. Friends of our friends. Okay.
It's
So
there
that
in
means,
it's there in the LinkedIn as well, sir. Like first connection and then second. Yeah.
so in that case, that is also being taken care of. So that means that is also used. That is, this technique is also used for recommendation system. 1 hop neighbor, 2 hop neighbor, 3 hop neighbors, and somehow. Okay, so those 2 hop neighbors are the friends of a friends. Means if F is at my circle, if F is my center of my graph, okay, my graph, not the whole graph. If F is my graph, so that means G, H, and C will be at the radius of, matlab, we're at the distance of 1. Then there'll be another circle. So this is the direct neighbors. The second 2 hop neighbors will be the range, or we can say the neighborhood size will be more. Okay, the neighborhood size of the 2 hop will be more as comparison to 1 hop neighbors. So they will be, if I put all those nodes into the outer circle, so that means it will be a bit more, like electrons in the outer valency shells. 3 hop neighbors, if F is my circle, so they all will be 3 hop neighbors, whatever it be. They can be f can repeat again for, okay. The thing is ki they will be the neighbors of a neighbors of a neighbor. Okay, so that means friends with two links in between. And the hidden thing is ki the range of accessibility from f increases with each hop. In one hop, my visibility is still my direct neighbors. In two hop, my reachability is neighbors of our neighbors. In three hop, my reachability increases. Now, I am able to cover a comparatively larger portion in a graph. Four hops means a bit more. So as I'm increasing the number of hops, the reachability of a particular node increases in the graph. Okay, and as per the researchers, there was I think a word written 6 degree of separation. Somewhere it was written 6 degree. Okay, I think in the previous slide initially. So 6 means, as per the researchers, what they have come up that with 6 hop in a social media, okay, with 6 friends in between, you can reach out to anyone. Matlab, any two individuals, arbitrary individual of the world, me and someone, Mr. X from other part of Antarctica, we may be connected to each other by 6 friends in between. Means we both will be definitely 6 or 7 hops away from each other. Okay, so that means the reachability has increased. So this is the meaning, or this is the we can say a concept behind the hops. Clear? Is it hops clear? Okay. Now, as of
Sir, one
now, you
question.
might. Ji, boliye.
Yeah, irrespective of number of hops, it's always objective is to find the shortest path or
Objective is to
find the shortest path
shortest path
between two nodes. I mean, whatever. Let's say if you are considering U and
okay.
V as the source and destination.
Okay. So if we'll have to do something on a graph, if we'll have to extract out, if we'll have to come up with anything related to the graph, in any number, any computation on a graph, the first basic necessary evil that we'll have to do is we'll have to come up, we'll have to, where the pen is, why I'm not able to figure out where the pen, acha, it is by default. Okay, it may be, the first and the primary thing that we all have to do is we'll have to compute we will have to execute the all pair shortest path algorithm on that graph. This is the first basic thing that we'll have to do on every graph if we want to process anything from that graph. So shortest path is already matlab, has to be there. This is a necessary evil. Now, based on those numbers, we will come up with few other things. So the first thing is, or we'll have to execute the all pair shortest path algorithm on that graph, and we need to store it in the form of a matrix. And that matrix is nothing. It is that D matrix which we were talking about, V cross V. It's ये सीधे सीधे क्या नहीं चल रहा मैच क्यों रहा है okay fine now Okay. So this is what this matrix D matrix, which we'll have to compute first. So that will be a shortest path. So from A to B, the shortest path length is of B. Let me shrink it and then it will be visible. I hope it is visible.
Yes, sir.
Okay. So that means this A to E, we have a path length, well, a path shortest path of length 2 from A to E through D. From A to F, we have a path length of 2. When from A to G, the shortest path length is of 3. So either 1, 2, 3 or 1, 2, 3. Okay. So this we'll have to compute. It may be possible that from E to F, the shortest path length is 4. Let me check. From E to F, 1, 2, 3, 4. Or there is another path. There can be multiple path. 1, 2, 3, 4. So there can be multiple path. Sorry, there can be multiple shortest path from from one node to another node, but all of those paths will be of the same length, which is that's why they all are shortest path. So ultimately, in one liner, we will be focusing only on the shortest paths, and there can be multiple shortest path between two arbitrary nodes. But as of now, we are not recording it. For the diameter purpose, I'm just bothered about the size of the shortest path. Number of shortest path, I'm not recording anywhere as of now. Okay. So this, now there are few terms which we need to read first. So there's one more term which we call it as eccentricity. Okay. So eccentricity means the minimum number of hops in which I'm just skipping this part. Sum ko chhod dijiye. So in which you just skip this. In which all connected pairs means, I'll explain this 90% part later on, but as of now you can ignore it. The minimum number of hops or the edges in between in which all connected pairs of nodes can reach each other. Okay, so that means connectivity. So that eccentricity is with respect to each node. Okay. So here from A, if I'm focusing only on one node at a time, so from A, I can reach to B by one hop. I can reach to C by one hop. I can reach to D by one hop. I can reach to E by one hop. I can reach to I can reach to E by 2 hops. I can reach to F by 2 hops. I can reach to G from A to G 3 hops. From A to H 3 hops. From A to I 2 hops. And from A to J 2 hops. Okay. So the maximum of all the minimum shortest path will be the eccentricity of okay. So this will be the eccentricity of a node. So eccentricity of B will be maximum of any of those. So maximum of all the nodes means reachability from B to all the nodes of a graph. So that means this row will be something. This is single source all pairs. Sorry, single source all destination. Here the source is A. Single source all destination for B. So eccentricity for B is 3. Eccentricity for C is 3. Eccentricity of D is again 3 because this is a max of all. Eccentricity of E is 4. It is because of F. Now, what does it mean? What is the physical interpretation of those numbers 3, 3, 3, 4? So from A, I can reach to B in 1. I can reach to D in 2. I can reach to F in 2. I can reach to G in 1, in 2, in 3, and so on. So that means if what will be the eccentricity of A? So means that this 3 means 3 is the largest hop which I'll have to take to reach to any number in any node in a graph. Okay, so that means if I'll have to if I'm talking about the connectivity from A to all the nodes of a graph. Okay, so what is my minimum connectivity? Minimum connectivity will be maximum of all the eccentricities. I think this, it might be confusing by meaning minimum and maximum, but as of now, let me explain it. Why maximum is means the farthest node from A is what? Farthest node from A is G and H only. So that means maximum I'll have to make 3 hops to reach to any node. Is the statement clear? From A, if I'm at node A, how many maximum hop I'll have to take so that I can reach to any node of a graph? That will be equivalent to the maximum distance from that node to any part of the node. So what does this 4 means? If I'm at E, okay, I can reach many nodes in 1 hop. I can reach many nodes in 2 hop. I can reach a few nodes in 3 hop. But for farthest, if I'll have to reach to F, I'll have to take 4 hops. 1, 2, 3, 4. I'll have to take 4 jump, either in this direction or in this. There can be multiple paths, but all of them are of 4 hop. 1, 2, 3, 4. So that means maximum number of jumps I'll have to make from E to so that I can say I can reach to any part of a graph. What is the maximum number? Maximum number will be 4. So I can say in 4 hops, I can reach to any node of a graph. So this is the clear-cut statement a node is making. So that clear-cut statement will be the eccentricity of that node. So E says, I need 4 hops to reach any node in a graph. F also says, I need 4 hop to reach any node in a graph. A says, I need only 3 node. I need only 3 hop to reach to any part of a graph. Okay, so those will be the eccentricity. Whereas I over here will say, I require only 2 hop to reach to any part of a graph because 2 is the maximum number. You can just have a look. 2 is the maximum hop of I. So that will be the eccentricity of each node. And that is the physical interpretation of eccentricity of each nodes. Okay. So any questions regarding any of the number, physical, even conceptually or theoretically? Any doubt? Is this clear? Is this clear? Concept are cleared or not?
Yes.
So once, if you have calculated path, rest everything is just extracting out certain numbers from the graph, from that matrix. So first thing was the eccentricity of each node. Okay. So eccentricity of each node, 3, 4, whatever the number is. So that number has some interpretation. So that number will be the reachability. Clear? Any doubt? Okay. This 90% still pending. I'll explain, but be with me. Okay. Now, These are the eccentricities of each node. This is this is EA, this is EB, this is EC, this is eccentricity of D, this is eccentricity of E, F, and so on. This is the eccentricity of I. So I'll explain diameter first, then I'll come to the radius. The diameter will be the maximum of all the eccentricities. So maximum of all the of a graph will be called as the diameter of a graph, which is 4. What does it mean? What is the interpretation? It means that this 4 is the number that from any node of a graph, this is the maximum hop that anybody have to take to reach to connect two extreme part of a graph. Because this is 4 because of those. This is maximum. And what are they? This says that E and F are connected with the 4 hop. So that means they are at the two extreme end of the graph. Although structurally it says that okay, E and F are in the middle. Why I'm talking about those? Why I'm considering this as a two extreme of a graph? The reason being this can be explained in that way. If 1 hop neighbors, 2 hop neighbors, 3 hop neighbors, and 4 hop neighbors. If this is my center of a graph, so this is 1 hop neighbor, 1, 2, 3, 4. So that means E and F are 4 hop neighbors to each other. Okay, 1, 2, 3. So that means 1, 2, 3, 4, 4 hop to each other. So that's why that will be called as the diameter of a graph. End to end. So somebody have to take max of 4 hops to reach from one extreme part of a graph to other extreme part of a graph. So that distance will be called as the diameter of a graph. Okay. Whereas if this is a max function, so min function will be the radius. So what is the minimum distance that somebody have to take? Minimum of all those is 2. Okay. Now diameter is not half of diameter by 2 is not equals to radius. Okay, luckily that is 4, this is 2, but radius and diameters are not the half or the double. Diameter is the maximum eccentricity and radius is the minimum eccentricity. Okay, so please do not be confused by radius is the double of a half of diameter or diameter is the double of radius. No, that relation doesn't appears over here. Diameter is the maximum eccentricity, radius is the minimum eccentricity. Okay, what is the interpretation? The interpretation is that E and F, which are they, are the peripheral vertices. Means these are the vertices eccentricities. So vertices with the eccentricities equals to the diameter of a graph will be called as the peripheral vertices. Okay, these are the vertices which are farthest apart from each other, not from the center of a graph, from each other. Okay, so those are the peripheral vertices. In terms of if this is my hop plot, then these are the two extreme part of a graph. Whereas all those nodes whose eccentricity is equals to the radius of a graph will be my central vertex. Now, what is the interpretation of central vertex now? So that means if E has ये हिलता हुआ सिर्फ मुझे ही दिख रहा है, आपको भी दिख रहा है? It's shivering a lot. Is it for you all also?
Only you, sir. It's not.
No.
It's not shivering here.
Acha, for me it is shivering a lot. Okay. So that's why I'm moving back to the mouse pointer. So what does this mean? This means that this E is it's towards the center of a graph, because from E I can reach to any node of a graph with the eccentricity of minimum, which is 2. So E will be the central vertex of the graph. Sorry, I is the central vertex of the graph. I. Okay. So is the physical interpretation of all the words is clear to you? Eccentricities, radius, diameter, peripheral vertex, central vertex. Is it clear?
Yes.
Okay. I'll explain this. Please be with me. Now, there are a few more things. There are a few more numbers which can be extracted out. One is characteristics path length. Each node in a graph, consider the shortest path from it to every node of a graph, means row values. Take an average of all these paths. Okay. Means this value. What does this mean? If I take an average, this value is the average of all the path length, means shortest path length. So mean of certain number means what? This gives me the balancing point of the whole distribution. Okay, so this 1.8889 is the mean of all the eccentricities. Sorry, mean of all the shortest path from A to all the other nodes of a graph. From A to all. So on an average, I can say that on an average, A is 1.8889 distance away from all the nodes of a graph. Is it clear? If I say that A is on an average, it is 1.8889 distance away from any part of a graph. Clear? B is 1.7778 distance away from all the other nodes of a graph. So average path length of A is 1.8889, average path length of B is 1.7778, and so on. So average path length of D is 1, average path length of E is 2.44, average path length of E is 2.11, average path length of what is it? G is 2, H is 2, I is 1.5, and J is 1.8889. Okay. There are few more important information that I can extract out from the graph. Just after looking at those eccentricities, for me, I was a separate closest node. Rest A and E and F are the farthest node. Okay, so this is how I have classified till now. E closest center, E and F are at the farthest, and rest A, B, C, D, and G, H, they all belongs to one class with the eccentricity of 3. So that means I treat all of them as equal. For me, there was no difference between all these nodes, and there was no difference between E and F also, because for me they both were peripheral vertices. But among them, when I calculate the average path length, then I came to know, okay, so that means the average path length of E was 2.44, whereas the average path length of F is 2.11, which means E is more as comparison to F. So that means F, on an average, F is slightly closer than E. E is still at the higher side and F is slightly inside into the graph. Similarly, A, B, C, D and GH, these four nodes, I was considering all of them as same. Here, just by looking at those values, they all are same. But by this way, I can say, okay, so that means B is slightly inside. And those values are not equals to 3. Effectively, the average diameter is 1.889, 1.77, 1.882, 2. So that means I still can classify all of them, those 6, into 3 different categories. B separate, A and C in one set, and D, G and H in the third set in terms of connectivity, in terms of average path length. And among E and F, I can say, oh, F is slightly inside, but F is the out. F is definitely at the outer side. So F is the farthest values on an average. I, the average path length from I is 1.555. So that means it is effectively more closer, or if it is effectively deep embedding towards the center of a graph. Okay, and the next closely connected node was B with the value of 1.7778. So that means, for me, I have a new class for B. Earlier, B was an idiot for me. Now B is not an idiot. Okay, that means, the difference is not much. So that means there's not much difference between the central vertex and B. B is slightly far more better than what I was thinking about him. So that means B is better. So these are the few more values, few more interpretation that I can extract out about the graph, about the connectivity of the graph, about the density of a graph. Okay. So average path length gives me few more information deep inside about the connectivity of the graph. Is it clear? Anything to be explained now? Any query about the things which we have covered so far? So Rishabh, that no is regarding some concept that to be clear.
It was regarding some sound.
अच्छा अच्छा ठीक है. Okay, so that means this is clear now. Physical interpretation of all those numbers. Now, there's one more. Now, median of all the values, median of all the average path length was called as the characteristics path length, whereas the mean of all the average path length, mean of the mean, had given a different name. We call it as average diameter. Okay, so median of all the means is the characteristics path length. Means median of all the average path length is characteristics path length. Average of all the average path length will be called as the average diameter. Okay, based on your ISM course. How come those two, or what all spatial information those two gives? Median and the mean. This is for you. So characteristics path length means I've taken the average path length. Then median of all those path length is called as characteristics path length, and mean of all the path it as average diameter. So this is only a slight conceptual difference between characteristics path length and average path length. It is the median of all those means, and this is the mean of all those means. But conceptually, what is the difference between those both the values? And why we want two different values? This is for you all. Anybody can unmute yourself and answer the question. So median of all the average path length comes out to be 1.944, whereas the mean 0.95556. So there is still a difference between two. How can I interpret that difference? And how can I interpret those values? I'm expecting an answer from you.
So, median focus on the center actually, and mean is like sensitive if there's any outlier there, right?
Fine. Good. Yeah, correct you are. So the moment I'm talking about median, median means I'm finding out the middle value of the part, middle value of the whole distribution. So I'm not bothered about the extreme values, max and min. I'm just trying to find out the middle value based on the count number of data points. So that we call it as median. So the characteristics path length value of all the average path length, whereas average diameter will be the balancing, because what does the mean is? Mean is the balancing point. Okay, so average diameter is the balancing point of all the average path length. Now, what is the difference? Median is not affected by the outliers, by the extreme values. Okay, whereas the mean is being affected by the extreme values. So that's why if some extreme values are there, and if you want to ignore them, if you doesn't want to take care of them, then characteristics path length can tell you something about the graph. Clear? Is it clear? Any value that I need to explain? Anything? I hope. Is it clear? Well explained? Any clarification required?
So just a small, the eccentricity that we found, right, will be the, like, even if you find the average that we did, that also always comes the eccentricity as the lowest average, right?
Sorry?
So the
Repeat it.
eccentricity, the lowest eccentricity is 2, which is for I. And also the
Really?
average path length will also be less for the I.
Hmm.
So this can be analogous, right? That can comment like, okay, so this can confirm our eccentricity with the average path.
I mean, that is, I think it will be obvious, because radius will be the node which have the minimum eccentricity.
Yes.
Okay. And that is minimum because it is well connected to, it is almost lying to in the center of a graph. It is very close to all the other nodes of a graph. So in that case, definitely its average path length will also be smallest.
Okay.
That's for sure. But to what extent it will be varying? So radius 2 and 1.5 be the difference between them. It's not guaranteed. It can be anything, but this will also be, if this is the minimum, then definitely for average path length also that value will be minimum. That's for sure. It will not be the case that the average path length will be greater than 2. Definitely it will not.
Thanks.
ठीक है. Any more thing? कोई चीज जो समझ में ना आए हो, कोई भी वैल्यू. If you understood the meaning behind the numbers, you can analyze them. And in the classification, in the whole graph neural network, the whole graph is not labeled. Some of the graph, part of the graph will be labeled, means some numbers will be available and some numbers will be missing. So based on the available numbers, you will be predicting the labels or numbers for the missing part, node, edge, or sub graph. So until unless you have a thorough understanding of those numbers, you won't be able to predict. You won't be able to utilize the knowledge given into that graph, or we can say hidden in that graph. Clear? Okay. Fine. Now, I've explained you the degree distribution. Okay. So the degree distribution based on the node degree was something like this. Was something like this. Okay. So in this graph, if this is my graph, there were few nodes with degree 1, there were few nodes with, there is no node with degree 1. There are few nodes with degree 2. There are few nodes with degree 3. And there are few nodes with degree 4. Okay. So total degree is 2, 3, and 4. Number of node, there was one node with degree 2. There were 8 nodes with degree 3. And there is one node with degree 4. So the degree distribution was something like this. Okay. Okay. Now, let us look at the new perspective of a degree distribution in terms of degree. So if this is my graph, and from that graph, I have extracted out the degree adjacency matrix. By default, not extracted. I will be storing the graph in a form of a degree distribution, in the form of adjacency matrix only. I will not take a photo of this graph and give to the CPU. I will be storing the graph in the form of an adjacency matrix only. Okay. Now, each node will have their own degree. So this is the degree of each node. So this will be the degree of total degree of each node. Okay. So there were 10 nodes with certain degree. When I sum all the degrees, so total DI comes out to be. Now, suppose somehow if I divide, if I take a proportion of degree of each node by proportion of degree of each node and the total degree of a graph. Okay. So degree divided by total degree. So this will give me some proportion. Total value will be equals to 1. Sum of all the proportions will be equals to 1 because it is the numerator is their degree and denominator is sum of their degree. So that's why total proportion will be 1. But there's one extra information which I can extract out from just in the proportion, means this node has 10% contribution in the form of a degree of a whole graph. This node has also 10%. This node also have a 10% contribution. This E has 0.06% contribution. And node I has 0.133% contribution in the in the form of a degree in the form of a degree in the whole graph. Okay, so that can also help me the dominance of any node or a set of nodes based on their degree. Clear? So this can be the another perspective of looking at the degree distribution. So based on their node degree. So degree distribution will not be the correct word. The correct word will be degree contribution. Here. Similarly, this is the degree in terms of undirected graph. If that would have been a directed graph, then the whole degree of a graph can be distributed into two parts, in degree and out degree. So it can, so again, it will be in degree contribution and it will be out degree contribution. Okay. Remember, these values are not same as this because this is this is an undirected graph and this is a directed graph. So it has a different connectivity. Here, the total degree is something different. In degree something different, out degree something different. I've changed the graph. So any doubt regarding this? Okay. I hope there is nothing. Let me come back to the main page and let me answer one by myself. Why intentionally I explain it in terms of columns? Why not in the form of row? The reason being is because normally whenever we are dealing with the graph, these rows are called as source. By default, we consider those rows as a source and those columns as a destination or a target. So if I'm trying to find, if I'm working on a D, so connectivity of D with every other node of a graph, then by default, it will be a column, value of all the columns in that row. Okay. So that means if I say this, if I apply the same formula over here, equals to max of all the values for undirected graph, it will be same. It will be 3. Okay, I can do the same. The value will be symmetric because my adjacency in undirected graph, this will be symmetric. But conceptually, if I'm working on those rows, it will be this value will be conceptually this value, this 3 will be size of the shortest path from all the nodes of a graph to A. So this will be the shortest path with the target as A. This is the all the shortest path from A to all the other nodes. I repeat again, this is the shortest path. This 3 is the shortest path from A to all the nodes of a graph. This 3 will be the shortest path from all the nodes of a graph to A. So here A will be the target, not the source, destination. So that's why I haven't solved it using row wise. That was intentional. Okay. If I have to work, if it's not necessary that all those calculations are working or are applicable on the directed graph, or only on the undirected graph, they are applicable for directed graph as well. If the meaning of all the concept of all the numbers will remain the same. So if this is my directed graph, this will be my all pair shortest path. Somehow I have calculated, somehow kya? I've calculated the average path length. I've calculated the eccentricities. नहीं, average eccentricity मुझे पहले करना चाहिए था. ठीक है. So somehow I have calculated the eccentricities. Not somehow क्या होता है? From the all pair shortest path, I've calculated the eccentricities. ठीक है. The radius will be the minimum of all. Comes out to be 3. The maximum, the diameter will be maximum of all the eccentricities, which is 8. So that means who all are my edges, who all are my peripheral vertices? This is my peripheral vertex. This is at the extreme. And this is the central vertex. Okay. Peripheral vertex means the vertex whose eccentricity is equals to the diameter will be the peripheral vertex. The central vertex will be the will be the node whose eccentricity is equals to the diameter of a graph, which is A. So that means H is my farthest node, A is my central node. Then I've calculated the average path length. Okay, so that gives me some more clarity about the connectivity. Based on that, I've calculated the characteristics path length. I should have hidden. Okay. Okay. So based on that, characteristics path length means median of those, and average diameter will be mean of all the values. So same, all the numbers are still valid for the directed graph as well. The numbers may be high, but somehow we can. Questions regarding this? Because I'm done with this. So before closing and moving ahead, I would like to answer any query, any type of a query which comes into your mind.
Just one question on degree distribution. Oh, so we understood like radius, diameter, and what all this signifies. And but degree distribution of the graph, what will it signify? Like what will it mean for like social network?
So degree distribution, I think we have already discussed this. Degree distribution is already discussed. The new thing which I have explained now is the degree contribution. So should I explain it on the terms of degree distribution or degree contribution?
The contribution is just a average, right? If you take it out and divide by the mean, right? It's just a mean. Like, okay, which node is contributing how much for the degree of the graph?
That means if there is any node having high connectivity, that means its contribution will be high.
Higher.
Okay. So that means this node has a higher degree, means this may be this have a this node broadcasted many messages, or this may, in terms of connectivity, they have a huge network. Okay. That means one hop neighborhood is high for D for this node I. That's again a one hop neighborhood now, but the connectivity.
Correct.
Okay. So that means its connectivity or its control over the graph is high. Reachability is high. Its influence is high. In terms of connectivity. Clear?
Yes.
So this is in terms of contribution in the social media. Now, if I have to explain the same thing in terms of degree distribution, means this 80% means 80% dominance is of what type of nodes? 80% dominance is of the
degree nodes.
Degree. Yeah. So somehow that's up to me in which manner I'm analyzing the network, but this distribution gives me the dominance of which type of node with what degree. Okay. So this is a different perspective. This is based on the type of degree, which we can say not type of degree, uh, uh, which degrees of I'll have to frame the sentence. This gives me the dominance of a nodes of certain degrees. Okay, and this gives me the contribution of each node. Now I'm not bothered about here in this degree distribution. I'm not bothered about any individual node. I'm clubbing all the nodes in one in terms on the basis of their degree. So the number of degree is important to me. In degree contribution, I'm bothered about the individual contribution of the node in the whole graph. I hope I have satisfied you and answered your
Yes.
query.
Yes, sir. Got it. Thank you.
Okay. Any more questions? It is not center skewed. I thought diameter is of the graph. What does the average diameter mean? Nirud, I think is your question answered now?
Yeah, thank you.
Okay. It gives us how skewed the nodes are. ठीक है. Now I think Bhupendra, are you satisfied? Because you were asking for an example, I have devoted full 2 hours for it.
Yes, sir. Thank you.
Okay, chalo. So let's move ahead. So now, I'll be moving to and fro over these slides and then explain. Okay, so now is hop clear? Now, if hop is clear, then the researchers, what they come up, they perform an experiment on any big graph, and they plot something. So starting from a node U in a graph, we find the number of neighborhood. Okay, NHU in a neighborhood of H hops. Okay, so that means what is the size of the neighborhood? So that means in the example where it was, this is NH1, matlab neighborhood of 1 hop. This is the neighborhood of 2 hop. This is the neighborhood of 3 hops. So that means the size of the neighborhood increases when we increase the number of hops. So the researchers, what they did is they plot the numbers. So they start from any node, and then they find the number of nodes in the neighborhood. So they started with 1 hop, then 2 hop, 1 hop neighbors, then 2 hop neighbors, then 3 hop neighbors, and so on. And they plot it on a graph, on a very big graph. Okay, the output was the experiment was performed on a very big graph. So they plot the hops versus the size of the neighborhood. Number of reachable pairs of the node means hops and the size of the neighborhood. What they observed was that with the increase of the hop, the size of the neighborhood increases. That is what we were expecting. Okay. This is what we were expecting, that the size of the neighborhood increases. Okay. But what they observed was something strange. What they observed that after certain hops, which they found out to be 6 on that graph on which they performed the experiment, they found out that the size of the neighborhood almost becomes stationary. Okay, so they call this property as a 6 that. So what does this mean? This means that if the size of the neighborhood stops increasing, so that means the whole graph is reachable. Okay, there is no more increment in the size of the neighborhood, means no new node is being added into the neighborhood. All the nodes are the same which are already being traversed. They are coming again and again. So that means at 6, the whole graph is reachable. So that means any two arbitrary node in a graph are connected to each other within a hop of 6. Okay, so that we call it as hop plot. Neighborhood versus the size of the hop. Here, okay. Now, one strange thing, I think I do not have much time, hardly 5 minutes. So I should end up with a small note. How to, okay, this looks difficult, but is there any easy way of calculating it? Yes, it is. Adjacency matrix. What is an adjacency matrix? Zeros and ones, whether they are connected or not. So those are one hop neighbors. A square will be all the neighbors which are at the distance of 2. So this A square will give me the 2 hop distances. A cube, matrix multiplication, simply matrix multiplication, will give me 3 hop distance from every node to every other node. Neighbors I can identify zeros and non-zeros. So which are still 0 means they're still not being connected, reachable with a distance of 2. And non-zero means they're reachable with certain distance. So those neighbors can be connected with a certain distance, but 0 and non-zero will give me the connectivity. And so on. So this hopping looks difficult as of now, but it's very easy to compute. It's just a matrix multiplication. So not that, because as a big graph, I want to solve it in a simple way. I cannot make the things complex or unsolvable. Got it? Okay, last thing. I think I should take 2 more minutes to finish my pending thing.
90%.
Okay, now in this, if I'm talking about simple graph, it looks easy. Where that pen has gone now. Okay, fine. Pen gone, yeah. Okay, I'll use this highlighter. Suppose I have a spatial graph, well, just an addition to this graph, in which there's a long tail, okay, of around 100 nodes. So that means the size of the adjacency matrix will also increase, but though all those nodes in the tail will not contribute much because they are one after the another. They have a degree 2 or some smaller degree as well. So if there are some nodes which are at the very high distance, not high, very, we can say big, larger distance from the rest of the graph, which makes my eccentricities and all the calculation bigger, although it is just a tail, it is just a chain, and that will add to all my eccentricity in radius, and all it will make all my values bigger. So what I can do, if so, in order to get rid of certain problem tails, problem creating tails, I can ignore that part of the graph. So that means if I'm working on till now, I was working on the 100% of a graph. But if I'll have to ignore some part of a graph because they are just a tail, and making my values bigger, so I can ignore them. Now read the definition again. So this is the minimum distance of hops in which some fraction, typically 90% of all the connected pairs of the nodes can reach each other. I can ignore those 10% which are making my value bigger. Or it may be possible that I may have some disconnected components. So those disconnected components can also be ignored. Got it? My time is over. But is it clear? Any more queries? Fine. I think the attendance. Okay, I know